Hey there, YouTubers! Hello there, Dr. Sheep here. Welcome back to another physics video. I think that sounds Irish. What do you think it sounds like?
Australian.
He's wrong. What do you guys think? Poll somewhere on the screen and leave a comment. Today we're covering Newton's third law of motion, which is the last of his three laws of motion. Now, if you want a shorter to the point video, I recommend you watch a shorter version of this video. Duh. Anyways, if you stuck around, it means you want to see some experiments. So let's go. Of course, we can't do experiments without knowing what to look for. Newton's third law of motion states that for each action there is an equal and opposite reaction. Action equals negative reaction. Now, just remember you can replace action and reaction with forces. Now imagine you have an American football with a constant two regulation, mass, and pressure. No deflate gates here, Brady. Now imagine you're Patrick Mahomes, Super Bowl 2019 MVP, and you go to throw a long 50-yard pass for a touchdown. The instant the ball leaves your hand, you, Patrick, exert a force on the ball, and the ball exerts the same amount of force onto you. Since the ball is much less massive than you are, the effect of this is more noticeable on the ball. To see a more noticeable effect on the thrower, imagine you're shooting a gun. A gun. And you feel the recoil. Funny thing about throwing a ball, if you apply two forces, you're applying two forces, a vertical and a horizontal. They average out to an angle somewhere between 90 and 180. And then the same thing happens in the opposite direction. And then, of course, through the power of math, the same angle is here as is here. Ain't that exciting? Math. Of course. Now, enough imagining. Let's do some actual experiments.
Here is a classic experiment of me dropping a tennis ball on top of a basketball. The basketball is much larger and therefore has a lot more energy to expel when it hits the ground compared to the tennis ball. Well, according to Newton, when the basketball hits the ground, we expect it to bounce upwards. However, it runs into the tennis ball which we dropped on top of it, imparting energy and applying a force, which launches the tennis ball in high into the air and leaving the basketball behind, which results in it not bouncing as high as it should. Now, instead of using basketballs, we're using people. As you can see, the same concept applies here with Kyle and I. I have way more mass, as you know, than Kyle, which causes him to fly back much further than me when we run into each other. It's like a human Newton's cradle. By the way, I do actually have a Newton's cradle. I got it a long time ago for a video we never actually did, but I broke it, and I could easily fix it with some super glue, but I can't be bothered. So here's a fun experiment you can do at home. Get a 2-liter bottle that no one cares about and have parental supervision or help put two holes in it. One at the top, one at the bottom. You can just put one hole at the bottom and specifically at the side of it, but you don't have to. As you can see, when I drop the bottle, the water stops running out the side. Now, why is that? Well, this is because there is no force stopping the bottle from falling. If the normal force, known as the ground force, was acting on the bottle, the water would run like you saw in the beginning. The water in the bottle are falling together in one system. What does that mean? Well, when the bottle is sitting there still, gravity is pulling the water through the holes in the side of the bottle. However, now that the bottle is falling, same as the water stops running out the holes because there's nothing for gravity to act against, if that makes sense. And so the water does not shoot out the sides. Now, Phil wanted me to mention how the bottle hole in the water bottle shoots the water out further than the top hole. This is due to the fact that more water is above the bottom hole than the top one. This is an equal and opposite reaction. Yes, one of my favorite demonstrations of Newton's laws, rockets. They're actually a demonstration of all of Newton's laws if you actually think about it. All rockets, in theory, work the same. Mass is shot out the bottom, typically, or one side of the object with a great velocity. This causes the bottle to accelerate in the opposite direction that the mass was thrown, or any object. In our case, the pressure from the air would not be great enough to get the air molecules to go fast enough to propel the bottle upwards very far. However, water has a lot more mass. Therefore, we don't need to get it to go as fast as the air to get the rocket to go as high. Therefore, if we got the correct ratio of water to air, you can get maximum air time.
Oh boy, what a fun, wet time. Anyways, if you have any comments, if you have any questions, please leave a comment. In the meantime, I'd like to thank you all for watching. Please like, comment, share, and subscribe. New videos every other Friday, 11 a.m. Central Time, and good night. Subs for trees, subs for trees, subs for trees, subs for trees. Oh, you're still here? I thought I told you to go home. Oh, you want more? I'm flattered. Check out the playlist. If you want exclusive content, check out my Instagram, Dr_Sheep_YouTube. That's all lowercase. If you want to help the earth, subscribe. When I reach 100 subscribers, I'm going to plant 10 trees. If you feel that's too small, then check out my channel chart where I lay out even bigger goals. Finally, stick around for the next 20 seconds to give me that sweet watch time. Bye.